For some time I've been trying to work out how to see understeer in my data from my data logger. So I have an AIM Solo 2 DL data logger, and you can see that the partner software for analysing the data from that is called Race Studio 3, which is what you see in front of you now. And what I want to know is, I mean, I subjectively can say I can feel the car understeering, and maybe I can look at video, like the video you see here on the right, and I can spot understeering in that video. But what I wanted was a more objective metric, a real measurement of that understeer. Now, one of the things I've tried to use is G-sum. If you're familiar with a GG diagram, which shows longitudinal and latitudinal acceleration in a circular formula, what's called a polar plot, and you may have seen this in Formula One documentaries where they show the drivers looking at the GG plot to find out where they can use more grip going around a corner. So I've used that. I sort of spread it out linearly, as you can see here, over distance, and this is the combination of longitudinal and latitudinal acceleration. So the thinking here is the tyres can only provide so much grip, so and that grip translates to longitudinal and latitudinal acceleration, and so if you exceed the acceleration figure, you're going to start to slide, whether it's at the front or at the back. So in my car, through looking at lots of data, I've determined that if I try to push the car mainly above 1.1 G of combined acceleration, so G-sum as they call it, if I try to push it above 1.1, it will start to understeer or oversteer, depending on the circumstances. But there is a problem with this figure, in that what you find is that it changes depending on the road surface, it changes depending on whether you're going up a hill. You'll get more grip going up a hill, you'll get less grip going down a hill. You get a big boost of grip as you bottom out in a hill. So if you think about Brands Hatch, as you come around Paddock Hill Bend, you go down the hill and you bottom out at the bottom before you start to go up to Druids. You get a heck of a lot of grip at the bottom there. You even get grip at the bottom of Bombhole going around Snetterton, so that's just a very quick slight dip. If you stay right across to the right and you clip the curb there, you go down and up. And in fact, I use that dip there to crank in more turn to turn the car faster than I would be able to do if it was flat. So it's got its shortcomings using G-sum. So I got interested in using the yaw measurement that comes from my car. So in my car, I've got this little device that sits under the passenger seat, if I had a passenger seat, but it would be there. It's in any standard 1 Series BMW. And it's a small accelerometer, and it's linked into the driver, the driving stability control, DSC, I think that's what it stands for. It's used for that, to detect if you're understeering or oversteering, and then it will step in and do whatever it does to try and get you out of trouble. You can use that measurement. For some reason in my data logger it's called gyro. So you can see in this plot here I've got BMW gyro. It says absolute because you get negative and positive values depending on which way you're turning, and I've just converted them all into positives. So we can get that figure. What you see here is me driving round a corner called Oggie's at Snetterton, and we're following a safety car. So we're during a race, we're following a safety car, so we're not going very fast, and I'm not understeering around the corner. That's the important thing. So what we see here is, as you see, the green plot is steering angle, and the yellow plot is gyro. If you want, we'll just call it rotation. Okay, so the yellow plot is rotation, and it's measured in degrees per second. So you can see that as I turn in, crank the steering wheel more and more, I get more and more rotation. And then as I ease off the steering wheel and start to open it out, I'm getting less and less rotation. Pretty much just as you would expect. But there is a problem with this plot. It's great and it looks really good here. But the problem is that, of course, this is rotation of degrees per second. And if I'm going faster, I'm likely to get more degrees per second. What I ideally want is degrees per metre of track. And you can see down here it says distance along the track. I'd prefer it to be degrees per metre. So what I did was I added a maths channel. I'll drop a link to a page that will give you all the details about the various maths channels I've used here. If you want to copy these, I'll drop that into the notes for this video. So what I did was I took the gyro figure and divided it by the speed of the car, and actually I've divided the speed of the car by 100 just to give me a more manageable number. So if I add that into the plot now, you can see it's this white plot here, and in this case going around this corner at a fairly constant speed, so you can see that we're going between 72 kph down to 53 and then back up to 70 something. Going around that corner, it pretty much tracks the gyro. These little bumps and troughs, you will get these. Sometimes this is noise in the data. It can be that running over something can cause this problem. But yeah, so to some extent you need to ignore some of the very fine detail of this. The main thing is you're looking at the basic shape, and it will become more apparent when we look at the next plot. Before I move on, there is a question about why didn't I use the GPS gyro setting that you get from the AIM data logger. And if we put that in, which is this one here, you'll see it's very erratic. Now, to be fair, I have a feeling the reason for this is because, according to the notes for the data logger, you have to have the logger vertical and you have to have the logger at 90 degrees to the direction of travel. And I know in my car it's definitely not at 90 degrees to the direction of travel. It's sort of slightly skewed, and also I don't think it's perfectly upright. I also think because it's mounted on something that's not completely solid, I think it shakes backwards and forwards, and I don't think that helps either. I mean, I've improved this a lot. You'll probably see in other videos that I've produced where I've tried to stabilise that data logger and its mount, but I can't seem to get it to produce nice smooth numbers here. You may have more success. Okay, so if you don't have the equivalent of a yaw measurement coming from your car, maybe you still can use this GPS gyro figure. You could do some smoothing, some things to filter out some of these lumps and bumps, and maybe that would give you what you want. But I'm not using that in this particular situation. Okay, so I'm going to remove that. Now let's move on to a lap where we have some understeer. Okay, here we are at the same corner, but going around it at full race pace. Just a quick word on these acceleration figures. You can see I've got the limit set to 1.1 G. So where it's red, it means it's gone above 1.1 G in both of these lateral and G sum figures. We'll see that actually in this case this has worked quite well as a proxy for showing the point where understeer occurs. But let's not jump ahead, let's just do this bit by bit. So we've got the same situation. Steering input is green, the green line, and then we've got the resulting gyro figure or raw rotation figure in degrees per second, and then we've got this other rotation number that I calculate by dividing the gyro figure by the speed. Okay, so let's wind forward through here. So you can see we're increasing the amount of steering input. We're getting more and more rotation, and then we get to this point here. And at this point here, I'm still winding in more steering angle, but my rotation is reducing. So you can see it's dropping away, and I keep putting in more and more steering angle, and it's still dropping away, the rotation. And in this case, my calculated rotation figure and the gyro figure both coincide. And there isn't much change in speed between these points. If you look there, the speed is 84 kph, and if I wind forward to, say, there, it's 83 kph. So, you know, that explains why they're very closely tracking together. Now I keep winding in more and more, and I keep getting less and less rotation. So I've definitely got understeer here, and in fact, if you watch the video on the right, you can see the car is understeering out towards the edge of the track. Okay, then we seem to grip up a bit, so the speed has dropped enough now to give us some grip, and now the two numbers start to diverge, and that's because we now have a lower speed, and so naturally the gyro rate would reduce because of the lower speed, but my rotation figure is correcting for that. So you can see they diverge, but we still have an issue where it does look as though we've gripped up quite well. So there we've got a figure of 36.75. Let's look at the peak figure back here. 36.69, yeah. So okay, so we've found some grip. It's gripped up because I'm going slower, and then basically we're tracking through here. You can see here it's dropped away a bit. I've got a feeling what's happened here is I've gone too far out to the edge, and I've probably got on a dirty area of track, and so my the grip levels drop, and so I'm getting more understeer, and then it grips up again, and we keep going, and then gradually we're unwinding the steering to come out of the corner. Now let's look at a very different type of corner. So this is a tight right-hander. You can see it up here on the track map. In fact, it's a bit more than 90 degrees, isn't it? It goes on and on, this corner. It's sort of, you think you've gone round the corner, and then it turns in a bit further on you. What I want to look at now is this corner here, Coram. So if you look at the little track map up on the right, it's a long sweeping right-hander. So let's see if we can look at that one, and I'm going to pick this lap here because that's the fastest time round this corner. So in this case, and I'm going to drop out the yellow plot actually, because we've already committed to using the this rotation figure, so let's drop that one out. Now what you see is a very slow increase in steering angle, and the reason for this is what I try to do is I try to stay around the middle of the track, sort of towards the outside, and then turn in towards the end of the corner. So if you look at the track map, I turn in towards the end of the corner and come to the right, so that I can then get the car straight, brake hard, and then turn into the sharp left-hander, because we're going around this corner quite quickly at 136 kph. So you know, I know if you've if you're driving a single seater, that's probably pretty pathetic, but in one of these cars, that's fairly fast. Oh, by the way, I can't explain this for the moment. We'll have a little talk about this lump in the middle of the G-sum plot in a minute. So we're increasing the steering angle, and what you can see is that the rotation drops away there. Now the way I'm responding to that drop away of the rotation is, if you look at the pedal here, which is the throttle position, the throttle pedal position, I ease off the throttle, then the car grips up again, starts to turn again, and then I keep it and hold it at that position, but I'm still increasing my steering angle, and I try and squeeze a bit more speed out of it, and I've got a little lump there, I'm not quite sure why that is, but then it drops away again, but I'm sort of just controlling it on the throttle. We get round to this point here, the grip has dropped away, so you can see again I reduce the throttle a bit, it grips up again, and this is how you go around Coram. You don't touch the brakes, because if you touch the brakes you're going to spin. So you go around Coram just by controlling it completely on the throttle. Now I am gradually reducing the throttle because, for one thing, I'm turning more and more, and I'm trying to make the car turn, so I'm putting in more and more steering input, and also you can't suddenly brake as you go into the left-hander. You have to slow it up a bit before you get it into a straight line and then brake and turn. At least I do. I'm sure there are other drivers who I race against do a better job of it than me, but that's how I do it. Okay, so you can see all the way through this. If you look at this point here in particular, look at the way the rotation has dropped right away. Don't read anything into the white line crossing the green line. It doesn't mean anything. It's just the way these are plotted on the scale. But it's dropped away quite a lot, and so what I've done is I've reduced the throttle again, and you can see it started to grip up again, and then I've tried to accelerate and it's dropped away again. So the car's sort of sliding around quite a lot, moving around underneath me as I go around this corner. Let's talk about this lump in the G-sum graph. One of the things you notice is I've averaged the G-sum figure over 3 samples. So I take 3 adjacent samples, it's called a rolling average, and I average them. That's to remove some of the noise out of the G-sum figure, and you can see that I've done the same here. This is averaged with the lateral acceleration figure. Now what I'm going to do is let me show you the raw G-sum figure without it being averaged. So if we add that in, now you can see we've got this really steep spike. I'm going to just let me rescale this just to bring it down. I mean, I've changed the scale now, so don't read into the fact that this is lower than this figure here. They're going to be about the same. It's just I've tried to bring it into so we can see the extent of the spike here. So we've got a very sharp spike, and what's happened is that's been averaged out, and that's caused this lump. Now that spike, I'm guessing, is due to lateral acceleration. It could be longitudinal actually. Let's have a look at the lateral one. Yeah, so we've got a bit of a spike in the lateral one as well, which all contribute to this. Next thing to do is look quite closely at the video. Let me see if I can make this a bit bigger. Okay, and I'm going to roll over the area of the graph. Now there is a slight synchronization error, between the two, so they're not perfectly synchronized. But if you watch the best thing to do is watch this wiper blade here as we go across the track. I hope you can see that it's bouncing up and down a bit, and I think the thing that's caused this is that the track there is obviously uneven, and the bouncing up and down has upset the accelerometers, and that's what's given me this impulse of acceleration, and that then has appeared on the graph. I think the lesson to learn here is when you're using averages like this, just be careful the way you're using them and the way you interpret them. It might be, if you see something that looks totally strange, which obviously this one does, it may be worth going back and looking at the non-averaged figure to see what that looks like. So what about oversteer? Well, yeah, I think we can use this same method to look at oversteer, and I'll look at that in a later video. So we've covered a lot. I hope you've found this interesting, and I'll catch you on the next one.